every modern building, every car, every aircraft, behind every curve lies one mathematical idea. But before we understand NURBS, first we need to understand two simple concepts: the world coordinate system, the local coordinate system. Every smooth curve begins with these three ideas. Let's uncover them. Imagine you are standing in a city. If someone asks, "Where are you?" you need a reference point, right? The same thing happens inside the 3D software. Every point need an address. That address is called coordinate. But coordinates only make sense when we know which coordinate system we are using. That's where WCS and LCS coming in. WCS. Think of WCS as the entire Earth. Considering the Earth center as the origin, we can point or measure anything relative to that. Same way, in WCS, it has one fixed origin, one x-axis, one y-axis, one z-axis. Everything inside the model ultimately known its location relative to this world. You can think of WCS as Earth's GPS system. No matter where you are traveling on the Earth, the Earth's coordinate system stays the same. Let's take a look at it in the Rhino. So let's say we are positioning one point. Let's find out the WCS of that point. Okay. So I am setting up the point and using deconstruct to find out x, y, z coordinates. Okay. As you see, we have to set the panels. Then we can find out each direction coordinates. Okay. So this is x and y and z. So now let's move the point to see how it changes. Okay. These are related to the origin point, which is 0, 0, 0. As you can see, the z point is completely 0, even though we are moving, because it's happening in the xy coordinates only. Let's move this point to z direction. Okay, let's go to the front view, then move it. As you can see, the z direction also becomes some values. Okay, now let's look at local coordinate system, LCS. Imagine you are assembling a chair. Instead of measuring everything from the center of Earth, you measure from the one corner of the chair. That's the local system. So every object has its own little coordinate system. The object can move, rotate, scale, and its local axis move along with it. An easy way to remember it is WCS, world's coordinates, LCS, object's own coordinates. Why do we need LCS? Suppose you have a door. If the door rotates, should every vertex be recalculated using world coordinates? That would be complicated, right? The door simply remembers where every point is inside its own local space. Then the software converts those local coordinates into world coordinates whenever needed. That's why LCS makes modeling much easier. Now that we know coordinate system, let's create a curve. Create a curve only with points. It creates a small straight lines. As a whole, when we look at it, it's look like a curve. but when you zoom in, it will still remains the straight line which create a whole curve. But if you want smooth curve, this is where NURBS come in. NURBS stand for non-uniform rational B-splines. Don't worry about remembering the full form. Just remember this. NURBS create smooth curves by controlling them instead of drawing every point manually. A NURBS curve is built from 4 things: control points, degree, knots, weights. Let's understand these things with the analogy. Imagine a puppet controlled by strings. You don't touch the puppet directly. You pull the strings, the puppet moves smoothly. NURBS work exactly the same way. The curve is enforced through every control point. Instead, the control points gently pull the curve towards them. Move the control point and only the part of the curve changes. That's why designers love NURBS. Now let's understand the 4 ingredients. First, control point. These shape the curve. Think of them as a puppet strings. If you move one of them, the curves move respectively. If you move the control points, the curve changes shape accordingly. Second, degree. Degree controls how smoothly the curve bends. Higher degree usually means smoother transition. You can type rebuild to see the degree and change the degrees. If you reduce the degree to 2, the curves moves towards the straight line which created the control points. If you go to the 1, you can directly see the straight lines connecting the control point. Third, knots. Knots decide how much influence each control point has. They control how the curve flows from one region to another. Think of them like a checkpoint that distribute the influence. Fourth, weight. Weights decide how strongly a control point pulls the curve. Higher weights, stronger pull. Lower weight, weaker pull. Here is the complete picture. First, control points are stored inside the object's local coordinate system. Then, the software evaluates the NURBS curve using the control points. Finally, the entire object is transformed into the world coordinate system for display. So, let's recap. WCS is the fixed coordinate system of the entire model. LCS belongs to each individual object. NURBS creates smooth curves using control points. And the 4 ingredients of the NURBS curves are control points, degree, knots, and weights. Once you understand this concept, everything about CAD modeling becomes much easier. In the next video, we will see how to analyze the NURBS curve with various components. That's all for today. See you in our next video.